Okay, let us look at example 6, which is this one here. So it's the integral of arctan of x with respect to x. So on this one now, it's the same procedure as what we did with lim, right? You see that we only have one function, it's an inverse string function. So we will put a 1 there because 1 multiplied by anything is that something. So our u in this case, same as in lim, our u is going to be equal to arctan of x. Du over dx is going to be equal to, so du dx in this case is going to be equal to 1 over 1 plus x squared. Remember the derivative of arctan is 1 over 1 plus x squared, right? And then dv dx becomes what we didn't choose as u, right? So dv dx is going to be 1. V is going to be x, right? So now we can write our formula for integrating by parts. The integral of u dv over dx is equal to u v minus the integral of v du over dx dx. Now if we write, we plug in all the terms that we have arctan of x with respect to x is going to be equal to uv is what? That's arctan of x and x. So it's x arctan of x, right? Minus the integral of v du dx. V is x, du dx is 1 over 1 plus x squared. So it's as good as we have x over 1 plus x squared with respect to x. So we have something like that. Now, what we are going to do is we are going to, because we need to solve this integral that we created in the answer. So this one is quite easy. That's u substitution. You're going to use u substitution there because you recognize, so it's also called the record, in this case it's called the recognition aspect of integration. So you look at your denominator, right? If you see that you are deriving your denominator and you are getting something that is in your numerator, you are going to just say the answer is lim of the denominator. But in this case, we can see that if we derive the denominator, we get 2x, right? So since we are getting 2x upon deriving the denominator, and we have x on the numerator, not 2x, right? It means we are going to have to adjust this a bit. So let me rewrite here because I don't have much space there. I'm going to have arctan of x dx equals x arctan of x minus, now the integral of x over 1 plus x squared. So I was saying, since we see that if we derive the denominator we get 2x, and here we have x, not 2x, right? We're going to adjust so that we get the 2x that we want on the numerator. We can see that if we multiply this integral by 2 over 2, we have changed nothing because 2 over 2 is just 1. So we can actually put this 2 inside and leave this one outside. So we can, let's just erase that and put it inside instead. So that's going to be a 2 there. And here we're going to be left with half. So it's half times 2, which is still going to give us that. So we have changed nothing. Now if we derive that denominator, we see that it gives us 2x, which is what we have on the numerator. So that means we are allowed to just say ln of the denominator. So when you see that by recognition, your denominator, the derivative of the denominator is equal to the numerator, you will say your integral is ln of the denominator. So it's going to be 1 over 2 ln of x squared plus 1 plus our constant of integration c. But here we still have to write everything else, which is x arctan of x, right? And we still have to write our integral, which was arctan of x with respect to x. So that there is our solution.